All right. So for today's class, we're going to be looking at solving some quadratic and linear equations. So last time we looked at when we have two linear equations, we plot both of them, and then we go in there and we find what the intersection is, and then that would be our solution. Now we're going to look at quadratic equations and how do we do that when we also have it with a linear equation. I hope we're getting used to these terms like quadratic, linear, and just how the graphs look. We're going to go through, we should be able to identify a solution when two graphs intersect, what happens at the point of intersection, and what does it mean when a graph doesn't have a solution. So when we're talking about linear equations, we're generally talking about a straight line, right? Let me spell this the right way. So we're talking about a graph that looks something like that. Oh, let me try doing a straight line. There we go. A straight line, all right? It could be in whatever shape or form, all right? Just a straight line. When we're talking about a quadratic equation, we're talking about one that looks like a parabola. Remember that word we talked about earlier on? Talking about something that looks like this, something that looks like that. Okay, so we're talking about linear equation, quadratic. Generally, with linear equation, something like y equals x. For a quadratic, we're looking at something like y equals x squared. Okay. So with quadratic, there's a squared portion to our with it, and then with linear, there's not. So we want to look at three different possibilities. Whenever we're graphing quadratic equations and linear equations, there are three different possibilities that we're going to find. The first one is where there's 2 points of intersection. So you know you have your quadratic, right? And then say, for example, there's a linear line that crosses it. So you'll end up with 2 points. There's a point right there and a point right here. 2 points of intersection. So those 2 points would end up being your solution. 2 points of intersection. That's one scenario. Now the next one, we're talking about 1 point of intersection. So you have your quadratic graph, and then you have your linear, and say for instance, the linear passes and touches, this is supposed to touch it, goes and it touches the graph once. So you end up with 1 point, okay, 1 point of intersection, all right? Let's make that 1 point. And I hope you already guessed what the next one is. It's gonna be no point of intersection. So we have that graph, quadratic graph, and then we include our linear graph. Oh, then there's no point of intersection for this one. All right, so let me go put this color right here. No point of intersection. And at that point, if there's no point of intersection, we could say there's no solution. With these, remember whenever we're writing just the format, like the points. For example, this point, we write the x value first, and then we write the y value. X value first, and then the y value, okay, for these 2 points. For this one, since it's 1 point of intersection, you're just going to have 1 point of intersection. And for this, it'd be no solution. So those are just like the three different possibilities whenever we're solving these. You'll realize on the worksheet, you have two different equations. You have the quadratic, and then you also have the linear, and then you go through and plot it. We are going to be using Desmos to help us with this, all right? So I have two questions that I want us to go through. The first one is y equals x squared minus 6x plus 6. And then the next equation is, let's use a different color actually. Orange, where are you at? The next one is y equals x minus 4. That's example 1. And then the next example is y equals x squared minus 16. And then the next one is y equals x minus 4. This is just a brief introduction. If you go through, it's kind of nice that you, whenever you do these questions, go through and try and identify which one is quadratic from which one is linear. And from this, we could tell the green is quadratic and the orange is linear, all right? The green has an exponent to the second power, which makes it quadratic. The quadratic graphs look like a U shape. It's a parabola, and they generally equal to the second power. Linear graphs generally don't have something raised to the second power. So these are the two questions we're going to look at, and we're going to head over. If you go to that sheet, you realize that I attached Desmos right here. If you click that, then it will open up Desmos for you. And let's actually go there now, so that we could work these two examples that I have up on the whiteboard. All right, so we're gonna go over back to Desmos, and let's put these two in, all right? Let me write these down. So the first one I'm gonna put in is example 1, right? So it was y equals x squared minus 6x plus 6. And I'm actually going to change this. Oh, I thought I could change the color. Maybe I can. But then that's the first equation, right? That quadratic. And then the next one was y equals x minus 4. So we put those two equations in. We did the quadratic, which for this one, it's in blue. And then we did the linear for this one, it's in green. And then I'm going to zoom in a little bit so that we can see the 2 points of intersection. You remember we talked about one of the solutions might end up having 2 points of intersection. This is one of them, okay? We realize that this point right here is 5, 1, because it's at the x5 and then y is 1. And I could actually put this in right here. I'll put in that 0.51, and then it will highlight it for me. The next point right here says 2, -2. And remember, you do the x value first. 2, -2. So those are my 2 points of intersection. And I'm going to label them. There it is. 2 points of intersection with this. So I have my linear graph and my quadratic graph. Get them, put them in Desmos, and then I get my points. Zoom recording, and let's go back and do this other question now. So the first equation is y equals x squared minus 16. And then the next one is y equals x minus 4. And I'm going to zoom out so we could see the entire graph. So it drew my quadratic graph, and then it did my linear graph as well. I'm going to go in and I'm going to put the points in. The points for this one, the x value is 4 and the y value is 0. There's that point. And I'm going to click label so that it shows it up on my graph. And then for this one, my x value, 1, 2, 3, is -3. And my y value is -7. Remember, x value goes first. So there's that point. That's where both my graphs intersect, both my equations. And like I was saying before, if I take the point 4, 0, so I take that point 4, 0, and I put it here, I say the x value is 4, and I put it here where it says x minus 4. So 4 minus 4 is 0. So y is 0. That makes sense. So we do these graphs so that we could figure out the solution. Where these two graphs intersect is what the solution is for both of these graphs, all right? That's just a quick overview of when we're plotting quadratic and linear equations, and then just to find out how does it make sense, and why is it the way it is? What do the values mean? What does the intersection mean? And keep in mind, some equations might have, some questions might have two solutions, some might have one, some might have zero solutions.